Hello everyone, welcome back to my channel, and today is day 26 of our 100 days of DevOps. We are going to continue with our study of containers. So we've been looking at containers and CI/CD for the second phase of our learning. So for now, we are still focusing on containers. When we're done with containers, we are going to move to CI/CD. So, and in the past 4 days, that's since day 22. We've been looking at containerization, we've been looking at Docker, we've covered Docker lifecycle, Docker architecture, Docker commands, how to run your Docker images, how to write your Docker files, and the last video was on CMD and entry point instruction in Docker. We saw how both of them, makes our Docker container behave in different ways. So if you are coming across my video for the first time, and you want to learn anything that has to do with DevOps, cloud computing, feel free to check out the videos. You can start from day one, and you can go up to today. So we are trying to cover everything you need to know about DevOps, the foundation, so that you can be well equipped when we go into projects fully. If it's something that resonates with you, you can also do well to subscribe to my channel, and most importantly, turn on your notification bell, so whenever I post any new video, you will be immediately alerted and you can watch it and add to your knowledge. So without wasting more time, we're going to go into what we want to do today. So what we want to do today is quite simple, but also very, very important. It is very, very important that you understand what we are trying to cover today. And what are we trying to cover today? What we're trying to cover today is Docker volumes and data persistence. So this is one of the most important things that you need to be very, very good at when you're trying to do containerization. You need to be able to understand how the volumes work and all of that. So before now, let me go back to the architecture. So when I was explaining how the architecture works, I said everything is actually going through our Docker host. So whatever we are doing passes through the Docker host. The Docker client talks to the Docker daemon, which also which is on the Docker host, and then the Docker host, when the Docker host needs to get an image, it goes to the registry and pulls that image back to the host, and then the Docker client can tell the Docker daemon, which is on the Docker host, to actually run an image, which becomes a container. Like I explained, a container is a running instance of an image. So if you've not seen the video, you can do well to check the previous videos, and you'll be able to understand better. So let's go into what we have today, and I'm going to, let me try and see if I can copy this. So I'm just going to bring this image down back to this place, and I would also get this. So now, why is there a need for us to understand Docker volumes? So we have, let's assume that this is our host, and we have running containers. So let's just say hosts, and what we have are several running containers. So because of the way the whole containerization thing was actually structured, containers, I said containers are lightweight running instance of an image that you can easily deploy across your various environment and all of that. So the container actually does not have like the full package of the operating system. So because of that, there are some things that they don't have, such as persistent storage. So basically, you will hear something like people will say containers are ephemeral in nature. What it means is that whatever you configure, whatever changes you make in that container, the moment you delete that container, all the changes are lost. So basically, that is what it means. So all of these containers that you have here, we have like 4 containers running on this host. The moment you delete one, and let's say you delete this one, everything that has been configured in this particular container is gone. And that is where Docker volume comes in. Or that is where basically volumes comes in the sense that for you to, if you have any container that you need, let's say, okay, for a container also, container basically has just containers are basically read only. So they don't really have like the read write permission. They're basically, a lot of them are just read only. So they just read what is in your Docker file, which has been turned to an image, and then it just acts on that. They don't really have like the write. They don't write to it, because basically, they are lightweight and all of that. So how do we now protect against, or how do we save whatever information or whatever changes that we have done to in our containers, whatever configuration? Let's say, for example, now you pull in a Jenkins image, you've configured your user credentials, you've pre-configured your plugins, you've set some things, you've linked it to your GitHub repository, and you've been doing some things and all of that. And then for some reasons, your Jenkins container goes down. Once your Jenkins container goes down, all the configurations that you have done basically is lost if you don't have a volume attached to it. We are going to do a demo for this particular session, but I just want to actually like prep our mind, for us to understand and see the need for volumes when it comes to Docker. So now, how do we mitigate against this? So basically, this is where Docker volume comes in. Like I said, all you need to do is, the way to go about it is that you map a volume. Let's say you have a volume on your host, you create a volume on your host, and then you map it to the container, such that whatever changes that you make in your container is automatically saving on the volume that you have mapped it to. So whatever changes that you make, whatever configurations you make, as you're making those changes on your container, it is automatically writing to the volume which you have already created on your host. So once you do that, and once for any reason, if that container goes down, all your changes are saved in the volume that you have already created on your host. So as long as that volume is still there, it's still on your host, all you need to do is just spin up a new container, map that same volume to the container, and then all the configurations that you have before are still going to be intact, are still going to be there. So that's why I said Docker volume is actually very easy. It's just basically mapping your a volume on your host to the volume on your container. So that's basically how it is. But as simple as it is, if you don't really understand the importance of this, you might miss it, and it might cost you so much. So basically, that is the whole concept of Docker volume. It's just basically for data persistence, in the sense that you create a volume, you map the volume to the volume on your host to the volume on your container, and then once this container goes down, you spin up a new container, and then you map that same volume to the new container, and then everything is as good as, nothing happened. So that's the concept of Docker volume and data persistence. So I have a short note here. Yes, you can see when you create a container, Docker uses a read-only image, and then it creates a thin writable layer which is stored in this particular folder. But the moment you destroy it, it's lost basically. So it's just saying this layer is not designed for persistent storage. And that is why any file you need to write, or any file you know that is very, very important, you either mount an external storage on it to the container, and then secondly, you persist that data to the host using volumes. So that's just basically the whole concept of Docker volume. Like I said, I'm repeating it again. You create a volume, and then you map that volume to you create a volume on your host, and then you map that volume to your container, and then if the container goes down, you spin up a new container and use that same volume that you've created before. You still map it to it. So we're going to have a quick demo of how that will actually work. So before we go into our terminal, so there are two ways to go about this. And I call it, let me go to your documentation. Before that, we have something called volume mount, and bind mount. So basically, these are the two ways of, or the two prominent ways of mapping a volume on your host to a volume on your container. So basically, the difference between the two, there's not much difference. The difference between the two is that for bind mount, you have to create that folder. You create the folder yourself on your host machine. You create the folder yourself on your host machine. While for volume mount, there's a Docker CLI command which is called Docker volume create. So you use that command and then Docker creates a volume. So that's the difference. For the volume mount, Docker creates the volume for you. You use the CLI command and Docker creates a volume for you. While for bind mount, you create that folder yourself and map the folder to your container. So Docker creates that volume in this particular directory /var/lib/docker/volumes. You understand? But the volume, the location of the volume or how you want the volume to go about is not actually in your hand when it comes to volume mount, because you've left all of that to Docker. While for the bind mount, you are in control of it. You literally create a directory or you create a file where you want to map all of your volumes to. You might be wondering, since there are two ways, which one do you actually use? Personally, I prefer the volume mount because it allows Docker to use its own assessment of the environment to create a volume. So if I go to the documentation, there are I have the documentation for this. So this is for the volume mount. It said volumes are persistent data stores for containers created and managed by Docker. So it is managed by Docker. You can create a volume explicitly using the command docker volume create and then the name of the volume. So Docker will create the volume. So when you create the volume, it is stored within a directory in a Docker host. When you mount the volume to a container, this directory, blah, 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 and all of that. So where I'm going to is when to use the volume mount. So these are the advantage of volume mount. So volumes are good choices for the following cases. Volumes are easier to back up and migrate than bind mounts. So when it comes to migration of volumes, when you want to migrate a volume and all of that, it's easier to use volumes. When you want to do migration, you can manage volumes using Docker CLI commands or the Docker API. Then volumes can work both in Linux and Windows containers. Volumes can be more safely shared amongst multiple containers in terms of using the same containers, using the same volume across multiple containers. Volume is preferred and all of that. So let's say when to use bind mount. So I said when you use a bind mount, a file or directory on the host machine is mounted from the host into a container. So that means there has to be a file or a directory on it on the host machine which you bind to, to that particular container. So now when do you use bind mount? So when you want to share, or when you have something or you have a folder that you need to be in control over. You want to be able to edit that folder, work on the folder, outside of the containers. So you can use bind mount. So you can use bind mount when you are sharing source code or building artifacts between a development environment on the Docker host and a container. So when you want to create or generate files in a container and persist the file into the host file system, you can use that. When you want to share configurations and all of that. So that's the use cases for both bind mounts and the volume mount. So both of them are used to create and map volumes from your host to your container, but they have their strong points. So depending on what you want to do, that would now prompt the choice that you make. So we are going to go to our terminal and I'm going to show you how you can use both the volume mount and how you can also use the bind mount. So first we confirm who am I, just to be sure. So we have our present working directory and we have do ls these are all of the things that we have been doing in the past weeks. So let's check images. I'm basically going to be working with an Nginx image. So we don't have an Nginx image. Let's pull Let's pull. So basically, this process is what I explained on the first day. Your host sends a pull request to your Docker daemon, and then your Docker daemon checks your host. If that image is already there, then it uses it. But since the image is not on the container, it goes to the Docker hub. You can see it here, pulling from libraries slash nginx. So it goes to Docker hub, and then it pulls that image to your Docker host. So I'm going to pause this video for the image to be pulled, and I'll be back once the image successfully pulled. So we successfully pulled our nginx image. Let's confirm Docker images. Okay, so we have it here. So let's run our nginx image. Docker run. I'm going to run it in a detached mode, and I'm going to map it to port 8000 on my host. So nginx default image is port 80. So I'm going to do nginx. I'm sure by now, if you've been following the previous video, this is something that is no longer new to you, where we use our /-d and -p, you know how everything works. So when I click enter, it gives me the ID. So when I do docker ps, so we can see that its nginx is running and it is mapped to port 8000. So let's go to our browser. I deliberately used nginx because there's something that we have worked with before, so we already understand how or what to expect from our nginx image. So if I click on enter, this is not what I'm supposed to see. It to a different port. Let's say port 8005. So let's check. Let's see 8005. Okay, so we have welcome to nginx. If you are seeing this page, the nginx web server is successfully installed and working. So this is what we are supposed to get. This is the normal response that we're supposed to get when we just used our nginx. So now let's go into our container. Let me clear this. So now we're going to make changes into this particular thing displayed on our screen now, and we'll see it. So let's do docker exec -it, and then your container image and bash. So we're in our container, and I do ls. So we can see that when we exec into the container the previous time, we could see that our write-up or HTML file was stored in /url/shared. So let's go there. So let's do nginx. Yes, so we do ls, and let's vim index.html. So now we don't have vim. So we have to install vim. You do sudo apt update and sudo apt install -y vim. So this command would, okay, it is sudo apt get. I think it should be apt get. This command is supposed to, let's see, sudo. Why is sudo not working? I guess I don't need sudo for this. Okay, so I actually didn't need sudo. So what I'm doing is that I'm updating before you before you install any package, like I've said this before in one of my videos, it's important that you update your repository first before installing any package. It's just basics now, best practice and all of that. So now that we have it installed, so I can now go and vim index.html, and let me make changes to this. If you're seeing this page, let me delete some things. So if you're seeing this page, we are testing Docker volumes and data persistence. So let's save, and let's go back to our page and let's refresh. So you can see it. If you're seeing this page, we are testing Docker volumes and data persistence. So now we have already made a change to this particular index.html file, and it's on display now. So what we're going to do is that we are going to kill, or we're going to stop this container, and then we'll spin up a new container. Remember, we've not created any volume. So we'll spin up a new container and try to, see what is in the container and, confirm if the changes we made here is still the same. So let me exit from this. Let me use docker ps docker stop, and they will stop the container. So let's run a new container. So we're going to run a new nginx container with the same port. We're mapping it to the same port 8005, but it's a new container. We'll check the difference because you see the difference in their ID. So you can see that this was 81EB, while this is F326. So it's a new container. So when I go back here and I refresh, you can see that the previous changes that was there is already back. So nginx web server is successfully installed and all of that. So we are now going to create a volume, make changes to the volume, map it to a container, stop the container, and try to restart it. So that's what we are going to do now. So let me also stop this container. We stop this container. Yeah, so let's do docker ps -a docker remove. So I want to remove all the nginx containers that I have here. So we have the three nginx containers removed. So the first we are going to do, we are going to start with we are going to start with a volume mount. And from our documentation, how do we create a volume mount? We use the command docker volume create. So we go to our terminal and we do. Okay, before then, there's a command to list the volume. So we do docker volume ls, and you can see that I have no volumes already on my host. So we do docker volume create. Let's do let's just call it nginx. So we are creating a volume called nginx, which we are going to map to our nginx container where we want to run it. So when I click enter and I run my command again, docker volume ls, you can see now that I have an nginx volume which Docker created for me by using the CLI. So now I'm going to create an image. I'm going to run a container, but at the same time, there's the command to actually pass in a volume is -v. So let me go back and do docker run -help. So when I run docker run -help, you can see -v is to create a volume. So bind mount a volume. So when you want to mount a volume, you use -v. We can also use -mount, but I'm going to talk about that later because their syntax is a bit different. So let me go back and this is it. I'm going to do -v, and you have to put the volume that you've created, nginx, that's the volume that you've created will come first. You remember for the port, the host port, the port on your host will come first, and then the port on the container will be on the right. So it's the same thing for volume. The volume will be on your left, and then the volume that you're mapping it to on the container will be on your right. So hyphen hyphen. So where's the volume for nginx stored? It's hyphen usr hyphen share hyphen nginx hyphen html. Remember when we exec into our image and we went to the nginx configuration, we saw where the root is. So you are mapping this volume to where the root is. So whatever changes that you're making now is being mapped to the nginx volume that we have created. So when I run this, the image is already running. So when I do docker ps, the image is there. So I'll come back here. Since it's the same port, when I refresh, I have my nginx image still working. So now let me exec into this container and make that same change that I made before. Hyphen it, I get my container ID, and I want a bash shell. So when I do ls, I can see it. So when I do cd hyphen usr, that's our mount point share nginx html. When I do ls, vim index. So I won't be able to, because I see it's a new container. So I still have to install vim apt-get update apt-get installed -y vim. So I need to install vim so that I can be able to edit our index.html file. So once we do that, we'll save, and then we're going to reload or refresh our page, and we should see our changes. So just a few seconds. So that is done. So now let's vim this and let's go back and edit. We're going to make changes to this particular file. So if you are seeing this page, we are studying docker volumes and data persistence. We have mapped a volume to our container database. Just something, I don't even know how I came up with this, but basically just to show that the changes is there. So when I come back here, since it's running, I don't need to do anything I don't need to type any command to actually refresh. Since it's running, the changes will take effect immediately. So that's why you can see it here. If you see this page, we are studying Docker volumes and data persistence. We have mapped a volume to our container database, supposed to be our container database. So let me vim that again, just to be grammatically correct, to our container database. Okay, so come here, refresh. Okay, so we are now going to, let me exit from this container, docker ps. So we are going to stop this container, docker stop, and we're going to stop the container now. Okay, nice. So we're going to spin up another nginx container, and now I'm going to use this same command because we already have our nginx volume and we already confirmed that this is the mount point on our container, and we want to use the same port. So we are going to spin up a new nginx image, and you will see what we are going to get. So let me close this before I spin up the image. So when I click on enter, it brings a different image. You can see that the image ID is different. This is F9D25, while this is 8DA9F. So when I do Docker PS, so this is a new image. So when I go here and I try to 192.r since 8005. So when I click enter, you can see it. If you are seeing this page, we are studying Docker volume and data persistence. We have mapped a volume to our container database. So if you still have doubts, let me say, since we use the same thing, I'm going to stop this container. I'm going to stop this container so you can be sure that everything is proper. I'm going to spin up a new container, but I'm going to change the port number to 8007, but I'm still mapping this to the image, to the volume that we have created. So when I click on enter, we have a new image. When I do Docker PS, so you can see it's mapped to 8007. So let's go to our browser and let's do 192.168. So let's check 8005. So you can see that 8005 is not bringing any response. But if I change this to 8007, you can see, if you see this page, we are studying Docker volumes and data persistence. So that way, all of the changes that we have made is already stored in the volume that we created. So whenever you want to spin up an image, this is where people make a mistake or forget. As long as you have created a volume, you always have to map it. If you forget to map it, if you forget to map the volume, you will see that the changes will not be affected. Let me do it. Let's say I forgot to map this volume and I don't have it. So now I'm going to spin up another Nginx image and I'm going to change the port back to 8005. And okay, so when I do Docker PS, I have two Nginx image running. This one, which was mapped to 8007, and this is mapped to 8005. So let's go to 8005. So you can see that we are still hitting our Nginx web server, but you can see that it is the default index.html file that is being served, while this one that we mapped is what we have already edited. So that's the difference. So whenever you are trying to whenever you've created a volume and you're trying to map it, don't forget to always use the v flag. So whenever you're trying to use your Docker CLI, if not, you would not whatever changes that you've made will not show in the new image. So what I'm trying to say in a sense is that most people sometimes, maybe out of hurry and all of that, they forget to actually use the -v to map. So that's why I said Docker volume is actually simple, but it's also very, very important, and you should pay attention to it. So now we've created a volume using the volume mount. So we're going to look at bind mount now. We are still going to use our Nginx. Let me stop the images. Docker stop. We have this, and we have this also. Okay. So Docker PS -a. Let me remove all of these old containers. Do this also. Do this, and so I hope you understand everything that I have actually done so far. Basically, it's the same concept. The volume mount, the bind mount is the same concept. The only thing is that for the volume mount, we had to create a volume, which is Nginx, which will map to the container data store or the container mount point. So, but for bind mount, we'll have our own folder or file that we created. We are going to map that also. So I want to remove this volume, Nginx. So when I do Docker volume ls, I have nothing. So we are back to a clean slate. So now we are going to use a bind mount now to demonstrate Docker volumes. In our session on Nginx, we created a file. I think that should be in I can't really remember. Let's see. Okay. So we created an index.html file, which was quite different from what we had on our normal Nginx display homepage. So we are going to mount that file. The file is in /var/h-www/html. When I cut index.html, sorry, ls index cut index.html. Okay, so basically it's just like a system health check report, which was what actually was showing the previous time that I tried to access my Nginx image. So I'm going to be mapping this particular this report, this system status health check to our Nginx container, and I'm going to be using a bind mount to do that. So it's as simple as using the same image. We're going to use the same command, which is so now instead of me using Nginx, which is a volume that does no longer exist, I will just do /www/html. So I'm going to map this now to the mount point on our Nginx image. So for you to know, every image has a mount point. Every image has a mount point. So you have to know the mount point for each image. Jenkins has its mount point. Nginx has its mount point and all of that. So that's one thing that you need to actually be familiar with. If you don't know it, you can just Google search it. You get mount point for Nginx container. You see it there, and then you can use it. So when I run this, I'm going to do docker ps. So the image is running and it is mapped to 8007. So let's go and access our 192. So 8007. So instead of seeing the normal Nginx, we are seeing this. So we are mapping a folder on our host machine to the mount point on our Nginx container. So it's as simple as that. So that's the difference. That's the major difference between a volume mount and a bind mount. So basically, we've covered everything that we want to cover: how to map, how to create a volume using Docker volume create, and how to also map a folder on your host machine to the mount point on your container. So when I do docker inspect, just wanted to check something. So docker inspect, and I check this image. So I think there's a way you can locate the mount point here. So let me see. Yes, let me see. Okay, so you can see it here, mounts. You can see mounts. You can see type is bind. Source is this. Destination is this. So that's one way that you can locate. That's another way you can locate the mount point of a container. So just do docker inspect and the name of the ID of the container. You can also see it here, binds, and you can, docker inspect gives you a general, like a detailed information about a running container. So now I mentioned something that if you do docker run -help, that's the last thing we'll be doing for today. I said there are two ways you can mount a volume. You can use the -v, and then you can use the -mount. So they are the same thing, they do the same thing, but their their syntax is different. So let me do cd docker stuff. Let me stop this container. Docker stop. Sorry. Docker ps. Docker stop. This. Okay. So let's go to our documentation, and if I reload this, of course, I won't see anything because our container is not running. So when I go down, you can see the syntax. There's docker run -- mount. But when this is more detailed in the sense that you specify the type is volume. If you want to use a volume mount, if you're using a bind mount, the type will be bind. So you can see in general, -- mount is preferred. The main difference is that the -- mount flag is more explicit and support all available options. You can volume, you have to do sroc, that's the source. You put the volume name, the destination, the mount part. You can also use you can indicate read write. It has so many options. You can see it here, the source, destination, the volume subpart, if it's read only or it's read write, volume options and all of that. Why for the -v, you just specify the volume and the mount part. So if you come to bind mount, if you also scroll down, you'll see it here. Type is bind. It's the same thing. Basically, they do the same thing. It's just that they have more flags than the -v, which is just your host part and the container part. So let's use, since we've already talked about, I'm just going to do one. I'm just going to use the bind. Just going to use the bind mount. So it works for both the volume mount and the bind mount. Basically, the difference is that you just have to specify the type of volume mount you want to actually do. So let me clear this. I'll do the same thing. I would run this. So docker run, I want to run it in a detached mode, so -d. So the mount type is bind, but most of these things you don't really have to stress yourself about it. The syntax are usually on their documentation. That's why being able to use documentation pages are very, very, very important when you're doing not just DevOps, tech as a whole, because you really can't have everything in your head, and that's even stress. So our source is going to be /var/www/html, which was what we used before. Our destination is our mount point on the container, so which is usr/share/nginx/html. Then we can use our port. So I'm going to use a different port. I want to map port 8008, map port 80, and then nginx. You can see that the syntax of this one is longer, but it is more detailed. Anybody that is seeing this will say, okay, the type of the mount is a bind mount. The source, that's the one on the host, is this. The destination is this. The port, it's more detailed than just using the -v. But if you want something maybe a little quicker and you don't really have to put so many flags in it, you can just use -d. They both do the same thing. So when I run this, I'll get docker ps, and it's running. And when I come and port is 8008, so when I come and I do 8008, so you're supposed to see, so we have it here. So basically they do the same thing, -mount and -v, they both do the same thing, but their syntax is just different. That's the only difference between the two. So we've already covered what Docker volume is. We've seen different type of volumes, which is the volume mount and the bind mount. We've also seen the importance. We've done a demo on how to actually map the volume on your host to the volume on your container. We've also seen two different syntax to use when trying to map Docker volume. I really hope that you have learned something in this particular video. And if there's anybody that you know that needs has been struggling with Docker or Docker volume, you can do well to share this video to them, or you can even share the channel or the playlist to them so they can come in, they can watch the video from the start, and benefit from whatever I'm actually putting out. So we're going to continue in this progression tomorrow. Tomorrow we're also going to cover something very, very important, which is Docker networking. Networking is very, very important in every area of tech. So we're going to cover Docker networks tomorrow, or Docker networking tomorrow, however you might want to call it. So that'll be all from me today. I'll see you again tomorrow. Cheers.